Hey guys, video 2 here for Algebra 2 after school. Same thing, 10 questions. One or two of them are going to be kind of repeat topics for the most part though. Some new ones in comparison to the last video. So for the first one, similar to what we've been doing in Unit 5, we'll say this is a radical problem. And we want to solve for x. And to do that, first thing we want to do is get rid of this negative 2, so I add that over. And after that, I want to divide both sides by 3. And I want to get to this x that's underneath the radical. To undo something that's under a radical, you square both sides. So when I square the left, that radical goes away. And then I square the right, because whatever you do to the left, you do to the right. I want to solve for x, so I'm going to add 4 to both sides, and x is equal to 20. Okay, the second problem compares exponents, a positive exponent versus a negative exponent. So if we looked at the problem, let's say we have 2x over 3 squared, and I want to compare this to 2x over 3, same exact thing, but I'm going to raise it to a negative 2 power. So we're going to do both problems here and see if we can compare the difference. So when you square a fraction, first off, or when you raise a fraction to any power, you raise the top and you raise the bottom, and you raise everything that's in there. So for the top, I want to square this 2, square that x, and square the 3 on the bottom. And 2 squared is 4, and then we have x squared all over 9. Now the difference here when you come over to the negative exponent means to flip it. So I want to apply this negative 2 power to everything. So this is 2 to the negative 2, x to the negative 2, and then 3 to the negative 2. And when you think about a negative exponent, you want to evaluate it as if it was positive and then flip it. So side example, if I just said 3 to the negative 3rd power, well, I say, well, what is 3 to the 3rd? 3 to the 3rd is 27, but this exponent's negative, and negative means to flip it. So 3 to the negative 3rd would be 1 over 27. So keeping that idea in mind for right here, 2 to the negative 2 power, well, 2 squared is 4, but it's a negative exponent, so I flip it. So I'm going to bring my 4 to the bottom. X to the negative 2, well, x squared is just x squared, but it's a negative exponent, so again we flip it. Likewise, when it's on the bottom of a fraction and it's negative, we're going to bring it up to the top. So you can flip things from the top to the bottom or the bottom to the top. So when I say 3 to the negative 2, well, 3 squared is 9, and then when I flip it, I get 9. So that would be 9 over 4x squared. And if you notice here, these are the exact opposite of each other. Over here, it's 4x squared over 9. When I have the negative exponent, what did that tell me to do? Flip my problem. Okay, the third one is the sum and difference of perfect cubes. And to this point, some of you guys have still tried to get by not memorizing this or not learning it. So for once and for all, we need to go through and actually learn how to do sum and difference of two perfect cubes. So what is the sum? It means plus, or if it was the difference, it'd be the same problem, but a minus. And what is a perfect cube? So my cubes, perfect cube roots, 1 times 1 times 1 is 1. 2 to the 3rd is 8, 3 to the 3rd, 27, 4 to the 3rd, 64, 5 to the 3rd, 125, and we can keep going here. So when I see two different cubes, now as far as x goes, x to the 3rd is also a cube root. Why? Because x times x times x is x to the 3rd. So when I look up here and I see this is a perfect cube and that's a perfect cube, and I'm adding them, that's the sum of perfect cubes. If I look down here, likewise, this is the difference of perfect cubes. So we want to kind of think of this as a blueprint. So they give us a rule. When I have the sum of two cubes, this is just a real generic way of saying the sum of two cubes. To factor that, we end up with a and b, a squared, ab, and b squared. So I'll give you a second here to look. A to the 3rd and b to the 3rd. Now this is going to be the same exact thing if we did the difference, only we're going to change the symbols. So you're going to get the same exact thing, which makes it nice. You only have to memorize it once. So it's the same exact thing. How do I go from a to the third to a? You take the cube root. How do I go from b to the third to b? You take the cube root. How do I get a squared? Well, I already have a, so square whatever you came up with here. That takes you to a squared. How do I get ab? Take this one and this one, multiply them, and that gives you the ab. How do I get b squared? Square the last one. And now the symbols, when you add, is plus, minus, plus, and when you subtract, is minus, plus, plus. If you notice, the back symbol is a plus no matter what. The front symbol matches what you're doing, sum or difference, and the middle symbol, wait for the bell, the middle symbol is the opposite of whichever you're doing. So again, back symbol is always a plus, front symbol always matches what you're doing, sum or difference, middle symbol always the opposite. So let's go through and see if we can apply this. So let's say we had 8x to the third plus 125. So we're going to do this first one up here, and we'll say this is the sum of two perfect cubes. So this part right here is my a to the third, and this is my b to the third. So how do I go from a to the third to a? Take the cube root of it. What's the cube root of 8? 2, and the cube root of x to the third is x. What's the cube root of 125? 5. Keep going here. How do I get a squared? Square the 2x and get 4x squared. How do I get ab? I take 2x times 5, and that gives me 10x. I square my 5, and that's 25. I want to put my symbols in now. It's a plus, so plus, minus, plus, and you're all done. Okay, our fourth problem is going to be an inequality graphing. So let's say we have y is greater than 2x minus 1, and let's compare this to y, let's say 2y plus 3x, and we'll say that's less than or equal to 6. So for the first one, it's already solved for y, so we can go ahead and make our graph. And what do I know? My y-intercept is at -1. Slope is 2, which is really 2 over 1. So I go up 2 over 1, make a dot. And I'm going to connect these, but it does not say or equal to, so we're going to use a dotted line. If it was or equal to, which we'll get to that in a minute, it would have been a solid line. And with an inequality graph, you got to remember to shade. Greater than makes us think up, so I want to shade everything above the graph. Over here, I want to solve this out for y. So I'm going to say 2y is less than or equal to -3x plus 6, because this is a positive 6, right? And then I want to solve for y, so divide everything by 2, giving me y is less than or equal to -3 over 2x plus 3. Now I have this solved out for y. Go ahead and make our graph. Where's my starting point? 1, 2, 3, make a dot. Slope's negative, so negative lines go this way. So I want to go down 3 and over 2. This one is the or equal to, so it's, going to be a solid line. And this one is less than. Less than makes us think down, so I will shade everything below the line. Okay, our next problem is going to be solving a system of equations. So we'll say this is number 5. And let's say we have y minus 2x is equal to 4, and y plus 3x is equal to -2. So before we start to do this, and again, this is a system of equations, okay? And system of equations, the answer to a system of equations is where your lines intersect. So first off, I want to solve these both for y. So we'll say this is line 1 and this is line 2. So from line 1, we have y is equal to, add that over, 2x plus 4, and in line 2, subtract the 3x, so y is equal to negative 3x minus 2. And here are my two equations. So what do I notice? I see they're both linear. So if they're both linear, that means they're both lines. So if I draw two random lines, I mean, we'll pinpoint these in a second, but if I just draw two lines, there are only possibilities that they're going to intersect in one place. Now, if they were parallel lines, meaning they went in the same direction, then they would not intersect at all. So my only two real choices here is I'm going to have no answers, or I'm going to have one answer. Now, unless they were the same exact line, in which case you would have, infinite answers, but I'm not really interested in that right now. So I want to figure out, where do these two lines, where do they intersect? So to do that, again, there was three ways to do this, remember, in class. We said substitution, elimination, and for our purposes right now, I just want to look at how we do this on the calculator. So I'm going to turn our calculator on and go to y1. I'm not sure how well you're going to be able to see this, though, but I'm going to try to get it held up here. And for y1, we're going to plug our two equations in. So the first one is 2x plus 4. So 2x plus 4. Our second one is negative 3x minus 2. So you can see there we have them plugged in. We want to do a zoom 6. And when we do our zoom 6, see they intersect somewhere over towards the top left. And I want to figure out, well, where is this intersection point? And again, notice it's called an intersection point. So to find any type of calculation on your calculator, above the trace key in yellow, you should see calculate, C-A-L-C. To get there, I hit second in the trace key, so second calc. And I want to do the intersection. First curve, we just hit enter. Second curve, we hit enter again. And now when it says guess, you want to line up your cursor directly over top of the intersection point. Let's see if we can get it there. So right over the intersection point and hit enter. And I know it's hard to see here, but you should be coming up with negative 1.2 comma 1.6. So I would, my advice would be to try this problem while you have the video here. Make sure you can make the calculator give you the same answer, and then that way you can, verify you know what you're doing. Okay, the sixth problem we're going to do is very similar to the last one we just did. So it's another system of equations, and we're going to solve it. This time, though, we're looking at, let's say, y is equal to x squared plus 2x minus 8, and y is equal to, let's say, 2x plus 1. So in this case, I already have them both solved out for you. If they weren't solved out, make sure you get y by itself for each of these. But now, what do I notice this time? I see, well, this one's quadratic, and this one is linear. So if I start making some sketches here, I could have, here's a quadratic, so here's a parabola, and here, is my line. And if you remember, the solution to a system of equations is where these two intersect. So in this case, that doesn't happen. So I have 0 answers. What else could I have happen? I could draw this again, and here's my parabola. And let's say right on that point, kind of like a tangent line here, it only hits it in one spot. So I could say I have one answer. And what else could I say here? I could draw, here's a parabola, and here's my line. So what do I have? 1, 2 answers. So as far as a linear quadratic system goes, in other words, one of them linear, one of them quadratic, I could have no answers, I could have one answer, I could have 2 answers. And then to find out, what situation you have, you want to take these two, graph them in the calculator. So let me do that real quick here for you. You do that at the same time. So in your calculator, you should be going to y1, graphing x squared plus 2x minus 8. And on the next one, 2x plus 1. Do a zoom 6. You should see something like that. You should see, so in this case, we have 2 intersection points. So we're going to have to run the process twice. So hit second trace, go to calculate. Again, you want to calculate the intersection. Remember, system of equations, you want to do an intersection. So number 5. Again, first curve and second curve don't matter so long as you only have 2 equations graphed at the same time. The guess part now is important. because there's two intersection points. So we need to tell the calculator which one I'm interested in. So for right now, I'm going to go to the one on the bottom left as my guess. I hit enter, and it gives me -3, -5. Again, that's -3, -5. And I would run the same process to find the other intersection point. Second trace, go to calc, hit enter twice on first and second curve. And now for my guess, I hold in the right arrow, and I run my cursor up to the other intersection point, and it's going to give us 3, 7. So again, you should be able to follow along here during the example. Try this on your calculator. Make sure you're getting the same intersection points of -3, -5, and 3, 7. Okay, for our seventh one now, I want to back up a step and make sure we know the difference between a system of equations and solving a quadratic. So whenever it says find the zeros or the roots, and let's say we have f of x is equal to 2x squared plus 2x minus 84. Find the zeros. It means I want to set this equal to 0. So this is quadratic. I know that because my degree is 2. How do I solve a quadratic? Well, we have all kinds of ways to do this. So you can try to factor if you're good at factoring. You can complete the square, but nobody really in their right mind wants to do that, so we'll just cancel that one. You can quadratic formula your way out of anything, and you can also go through and try graphing. The fifth way is square root method, but remember that's only when the b term doesn't exist, so that's not relevant here. Some of you are going to say quadratic formula. As far as your SOL is concerned, I really would be suggesting use the calculator. What do we know about this? Whenever we want to find the zeros, here's my quadratic. In this case, it has two answers. Remember, the zeros are where it crosses the x-axis. So in this case, there's two answers. We can come over here. This one is an example of one answer. And then down here, that one's an example of 0 answers. So I would just graph this to have an idea of what you have going on here. So on your calculator, go to y1, graph 2x squared plus 2x minus 84, do a zoom 6. And if you look at your graph, you don't quite see the bottom of it, but I do see the two zeros. I know this just really keeps going and going and going, and then it curves back up. So this is more than enough to solve your problem. So I see two answers, and in this case, it looks like they land right on the line. I would still prefer you use the 0 button to make sure of this. Don't always assume. So to do that, go to the Calculate menu above Trace, so second trace. Now this time, though, we want to do the 0, the second choice. And now, left bound, right bound. So let me draw a little sketch here. Make sure we understand this. Let's draw a big big parabola here. Whenever I want to find the zeros, here is, we know where they're at. Here's one, and here's one. So when your calculator says left bound, well, first off, we need to pick what 0 do I want to find. So I want to find this one. Well, left bound, that's to the left of it. I would hit enter somewhere up in here. Then I'm going to bring my cursor down here to the right of my 0 and hit enter. And then when it says guess, I want to guess right on my 0. Get your answer, whatever it is, something, comma, something, and then we move on. I'm going to do the same process over here. Well, now I want to pick a point to the left of this 0. So somewhere down in here, hit enter. Somewhere up in here now for my right, and my guess is right on the 0. And again, you're going to get something, comma, something. And now you have your two answers. So remember, the difference between, another piece of paper, the difference between a system of equations versus finding the zeros. In a system, you have more than one thing. So for an example, a line and a quadratic. And your answers are where they intersect. And in a find the roots zeros type of problem, you only have one quadratic and nothing else, and the answer is wherever your graph hits that x-axis. Okay, for the next one, we're going to draw a sketch here. Let's make it an absolute values. Let's say we're going to go like that. And I want to come up with the equation for this graph. I want to do all kinds of things. I want to do the domain, the range, where does this graph increase, where does it decrease, and see if we can come up with the equation for this. So the domain, well, this keeps going and this keeps going. So as we go, this just keeps getting wider and wider and wider. So my domain is all real numbers, or negative infinity to x to positive infinity. My range, remember that's my up and my down, this is positive 2 up here, and it does not surpass that point. So my range, we could say, is less than or equal to 2. We could also say my range is less than or equal to 2 and greater than or equal to negative infinity. My increase, remember increase is whenever I drew the guy on the line, we run him down, he starts running from negative infinity, and as he starts running, he's running and he's running and he's running, and this graph, it's going up, right? It's going up and up as he runs. It keeps going higher and higher until he hits, this is 1, 2, 3. When he hits 3, this graph stops increasing. So it increases from negative infinity to x to 3, at which point this graph then starts going back down. So it decreases from 3 to x to positive infinity. The equation, well, what is the starting point, this big dot I got here now? It's 3 to the right. Well, how do we write this? So f of x is equal to, we know it's an absolute value, x, it's 3 to the right. Remember the left and the right is where we do the opposite. So if I want to go 3 to the positive, I say minus 3, and then it's up 2 units. Now what else is going on here is that typically an absolute value graph, remember, is the V shape, and since this one's flipped, we put the negative sign out front. Okay, for the next one, we're going to look at a real basic absolute value equations. Let's say we have 2 times the quantity of x plus 3. This is an absolute value. Minus 4 is equal to 10. So we get the absolute value by itself, add 4, and then divide by 2. When I add my 4, I'm at 14. Divide by 2, I get 7. Absolute value, remember, 2 answers. So I set it to the positive, and I set it to the negative. So go through and solve. X is equal to 4, x is equal to negative 10, and those are my answers. Okay, for the last one, let's do another end behavior questions. Let's say f of x is equal to negative 2x to the third minus 4x. So let's review the rules real quick. How do I figure out what goes on with the right? I look at the leading coefficient. Leading coefficient is the number out front. Ask myself, is this positive or is this negative? And if it's positive, the right goes up, and if it's negative, the right goes down. To figure out what the left does, I ask myself, what is going on with the degree? If it's even, my left is equal to my right. If it's odd, my left is the opposite of the right. So I like to make a little chart first, then sketch a graph, then write my final answer. What do I know? I see a negative, so my right is going down. I see my degree is 3, which is odd. Odd for opposite, meaning the left goes up. Again, this is not your answer, but this just gives me an idea of what's going on. If I drew a rough sketch of this, the right goes down, the left goes up. Now with this graph and this little chart, I should be able to write my answer. What is my answer? As x heads to infinity, so here's infinity, as x goes this way, what's going on with y, and y is going down. How do I say y? F of x approaches negative infinity. And then I go the other way. As x approaches negative infinity, so as x goes this way, what's my y doing? Y in this case is going up, so f of x is approaching infinity. Okay guys, that's it. That's 10 questions. Rewind if you need to. Other than that, come take your quiz.